Our next speaker is Jim Hugunin, talking about IronPython. And a couple of the speakers have asked me to remind you that there is a back page to your agenda as well, because there are some things going on later on in the day as well. So without further ado, Jim?
Hi. Can everybody hear me? Is the mic good? Excellent. So I'm actually going to be talking today. This talk is a talk in two parts. The first half of the talk is going to be about IronPython. A lot of you have probably heard that before, but I'm going to sort of summarize what we've been doing with IronPython and how we got there, and then I'm going to do the beyond part, which is what should we do next for dynamic languages on the Common Language Runtime. You've already had a little preview of the beyond part this morning, those of you who saw John Goff's talk of Ruby on .NET. So first of all, really quick slide. This is my why Python slide. And you know, there's all sorts of ways of talking about why dynamic languages are important. For me, they're important because there's a lot of users who love to use them. And that sort of makes them intrinsically important. Programming languages aren't useful unless people want to program in them. You know, Haskell happens to be, in my mind, one of the most beautiful programming languages in the world. But there's something about it that doesn't mesh with people's brains, so that the intrinsic beauty doesn't work very well. People love to use this. They use it for all sorts of things, like the CGI rendering in Star Wars Episode 2. The low-level stuff was all written in C, but Python scripts held all of that together. Now, you can consider whether or not Python is to take the credit or the blame for Episode 2 arriving, but it's mainly responsible for the computer graphics in Episode 2, which I think were pretty awesome. Storyline was somebody else's job. BitTorrent, interesting, useful application lots of people use, written in Python. Civilization 4 added scripting built in Python. I thought their dev team had one of the great stories about these scripting languages. They added Python to provide scripting support for other people so that people could extend Civilization. Gamers could extend it after they downloaded it. And then the dev team found that they liked it so much that it migrated its way into the core code, because a lot of the things that they were doing they could express more easily in Python rather than in C++. It's also used at a little company called Google, but let's move on. So this is now... So I love Python. I've been involved in Python for almost a dozen years now. There's another interesting thing out here that I probably don't need to explain very much today. There's this thing called the .NET Framework. Everybody's heard of it, right? Yeah, okay. And it has this amazing vision that it's a common language infrastructure. It's one runtime that can run all the languages in the world. That's at least what the initial press releases said. And it's pretty cool. They can share things like a JIT compiler, which is a really hard technical thing to develop. They can share a highly tuned garbage collector. They can share all sorts of metadata and reflection and loading support. What makes this different from a lot of dreams when people have said this, they were going to do this before, is that there's actually a lot of major languages in production use today on top of .NET. C#, VB.NET, Managed C++, J#, JScript.NET, Eiffel, COBOL, Fortran, RPG, Delphi, and I'm sure I'm forgetting something. But that's a fairly large set of languages that people are using in real applications today. That's pretty cool. And by having them all run on top of one framework, they can share a lot of common libraries and common infrastructure, and therefore really these languages can work very well together. And it's possible to have applications with parts built in each of these languages without feeling lots of sort of strong walls between them. So I thought this was pretty cool, but when I first heard about the CLR, I thought it was cool, and then I started reading that, well, it's good, but it's not good for the kind of languages that I care about. The kind of languages that I care about are Python and other dynamic languages. Those are the ones that I most like to write my code in. And this was a report about 5 years ago now saying that, you know what, this .NET thing is too slow to run dynamic languages. This is a quote from John Udell, who's one of my favorite reporters. He writes for InfoWorld. He said, this common language infrastructure is by design, which I find sort of the way that people attribute malice is always interesting. Knowing that one of the designers of the CLI, Jim Miller back there, actually worked on Scheme before he came to Microsoft, I can assure you it's not by design unfriendly to dynamic languages. Prototypes were built but ran way too slowly. What I wanted to know at this point was, how could Microsoft have screwed up the CLR so badly that it was worse for dynamic languages than the JVM was? Now, the reason that, of course, this question came to mind was before way in the past, I built a system called Jython, which is Python running on top of the JVM. Jython didn't run quite as well as the native implementation of Python, but it ran very well. People used it in a number of production applications. There's a lot of servers on the website that have servlets written in Jython. There's huge amounts of test code for Java systems that are built on top of Jython. So I knew it was more than fast enough for production use. So I decided to take a week, build a quick implementation of Python running on top of .NET, and write a short little pithy paper called Why .NET is a Horrible Platform for Dynamic Languages. So I took the week. I built a quick prototype implementation of Python. This was a little script that translated Python source code into C# source code. And what I found was it was unfortunately fast. This is the standard PyStone benchmark. It's the one benchmark that ships with Python. We can talk about benchmarks all day if you want to. We talk a lot about them in the IronPython project. What I found was this is number of iterations per second. I found IronPython was actually 1.7 times faster than the C-based implementation. So it was running very fast on top of .NET. It was possible to run this dynamic language on top of .NET and run it very fast. So, of course, instead of writing the short, pithy paper on what's wrong with .NET, I wound up coming to Microsoft, continuing work on IronPython and trying to figure out both how to make IronPython and make this particular dynamic language real. And the goal all along has also been how to make the CLR an even better platform for dynamic languages. Well, the first results from this, I think, talk mainly to the fickleness of the web. But all of a sudden, people are saying .NET is a good platform for dynamic languages, which is great. My favorite one is John Udell again, and I got to give him props for this because most columnists won't turn around and say, you know what, I was wrong when I said that the CLR is unfriendly to dynamic languages. It actually is great for them.
But why did he say it was wrong to begin with? Why did he say it was bad to begin with? What led him to believe that?
So, and this quote down here is actually my claim on it, that performance of applications is easily confused with the quality of the platform. In this case, it's performance of compilers, and a particular language implementation can be confused with the quality of the underlying platform. So the underlying platform is great for dynamic languages, but it turns out you need to be pretty clever. And I think John also gave you a lot of feelings this morning as he was talking about the difficulties of doing Ruby well on top of .NET. It's not as if you just do a quick mindless transformation and it works. You've got to be fairly clever to make it work well. I'll talk a little bit about why it does work well, but it was something that you need to put some work into. We're hoping to make that work less in the future. So this is the graph taken one more time, and this is roughly the same version of IronPython running on .NET 1.1 and 2.0. What you'll notice is that it got faster without any changes to the IronPython codebase, without anybody investing Python-specific effort. All of this was improvements to the underlying version of .NET from 1.1 to 2.0. This work, to be quite frank, went into making C# and VB.NET run faster. I mean, you all know that. That's why Microsoft's investing all of this work. But by running on top of .NET, IronPython's able to leverage that. CPython also got faster in the same time. CPython is the standard C-based implementation. But that was a lot of very Python-specific work. So a lot of folks had to go and improve the quality of the Python compiler and invest Python-specific work. You had folks doing the same thing for Ruby and for PHP and for all of these other languages. Well, if you can just ride this wave, it's an amazing wave to ride on top of. Here's a few of the features. I often get asked the question, what's .NET 3.0 going to do to finally be better for dynamic languages? And I always sort of take back and say, well, first of all, .NET 1.1 was pretty reasonable for dynamic languages. .NET 2.0 added a bunch of improvements that made dynamic languages run a lot better. One of these is dynamic methods. These are a way of doing code generation that you can collect normally. To be perfectly honest, it's probably not the right crowd to admit this, but this was how we caught up to the JVM, which actually had collectible classes. Now, .NET's able to do caught up and moved ahead, quite frankly in my mind. .NET's able to do very lightweight methods where you can generate the code, and that code can be garbage collected. We improved the performance of delegates. Delegates actually are used in huge amount in IronPython because most underlying dynamic language implementations use function pointers everywhere. We use delegates instead, which are a wonderful, strongly typed, safe, verifiable version of function pointers. Making their performance better, it's a wonderful implementation feature to have available. Generics, when generics were added to .NET, they were embedded deeply inside the runtime so that you have full reflection support working on top of them. All of the dynamic type information that you can collect about generics is available so that, again, a dynamic language can easily use generics. They were added in a multi-language friendly way rather than being added as this sort of compiler feature through type erasure. I think would be one way you'd do it as a compiler feature. And finally, all the general platform performance work, all the work to make things like string.split faster that somebody's doing just to make it wind up showing up for IronPython because we build on top of that infrastructure underneath. Okay, how many people in this room have written a compiler? Yeah, I love talking to crowds like this. Let me just say, most of the times I give this talk, I don't quite get that level of response. I think that's actually the second highest I've ever gotten, but there were one or two people who didn't raise their hands. I should ask you what you're doing here. So The,
Try it.
the IronPython compiler is a totally standard compiler architecture. There's nothing unusual in the architecture. It's a scanner, parser, code generator, and some runtime support library that the code generator uses. Okay, it's targeting the common language runtime. The same architecture as the C-based implementation of Python. The difference, of course, between IronPython and the C-based implementation is this box here. The C-based implementation has a bytecode interpreter. So it's tremendously faster than Ruby's syntax tree walker, but it's still a lot slower than a just-in-time compiler, and I'll talk about that in a moment. The support library is written in C# rather than in C, which is wonderful. I would write code in C# rather than C just about any day. It's so much more fun and more productive to be working in a language that is type safe and verifiable and has all of the other wonderful things C# gives you. I'm just waiting until we can use LINQ in the next version of the IronPython implementation. IronPython, by the way, is now written completely in C#, and I want to talk a little bit about that story because this positions me somewhere in the middle of the spectrum of dynamic language zealots, and there are quite a lot of dynamic language zealots in the world. The first 3 implementations of IronPython, I don't know if there's a way to move this up. I'm seeing people struggling, but I'm sorry. The first 3 implementations of IronPython were all written in Python. The first one was written in 1 week to get my first quick results. Then I spent 2 whole weeks building a really carefully tuned one, and 3 whole weeks building the last one to play around with ideas. And I find that working in a language like Python, I can play around with ideas so much faster, and I feel so much more free, and I can get the basic implementation ideas out. Then I knew what the architecture was. I knew what I wanted to build. I also knew that it was going to be a fairly long-lived project, or I hoped so, with a lot of people contributing to it. And I wanted the benefits that you get out of a static language, and the benefits that you also get out of something like Visual Studio combined with a static language like C#. So I moved at that point into C#. And for me, this captures the, for some problems, it's far better to use a dynamic language. For other problems, it's better to use a static language. The beauty of .NET is that you get to pick the language that works for the project, and you don't have to use a whole different platform when you decide to switch languages. OK, so here's compiling factorial in IronPython to Microsoft bytecode, to IL. And here's the exciting function that we're going to show down here. If n == 1, return 1. On the left, this is the CPython bytecode. So this is the bytecode that the Python engine emits. And over here is the .NET bytecode that IronPython emits. What you'll notice is a lot of similarities. CPython. OK, did I get my mic back? I've got a red light on the battery here if anybody wants to try and find me a new battery. I can always talk loudly enough for you, but nobody else will appreciate it. It's working, but there's a red light. So, OK. So CPython has a load fast 0, loads the first parameter of the function. So does .NET. I think pretty much every stack-based virtual machine I've ever seen has this function that loads a variable from the first parameter that was passed in. Those two match perfectly. Loading constants in CPython corresponds to a load of a static field here in IronPython. That's because in IronPython we use boxed integers rather than raw integers. Everything on the stack in IronPython is an object. It's an object because it's a dynamic language. We don't know what it is, so we can't use more primitive values. This equals function, though, does a whole bunch of difficult dynamic work. Equals in Python can involve potentially going out and checking functions and asking them if they have special methods that override comparison with this other thing you're asking it to compare to, or if they have things that override the equals method. A whole bunch of things can happen behind the scene in equals. So this one we just turn into a call to a static method. Go down, you look, branch happens to match exactly, return matches exactly, some other things match partially. Now, why would IronPython be faster than CPython? The CPython bytecode maps more closely onto the language than IronPython's does. Well, the reason IronPython's faster, of course, is the JIT. We have a just-in-time compiler that takes that bytecode and turns it into machine code. So that load fast here gets turned into a single move register instruction. Okay? Python has a bytecode interpreter. There's about 100 machine code instructions, more or less, to go around even the tightest loop of a bytecode interpreter. So this load fast 0 is about 100 times faster in IronPython than it is in CPython. This load constant also would be 100 times faster if you had a cache hit. It's going out to memory, though, so you never know exactly what the performance is going to be on that one. And then this call to the static method, well, it's roughly the same speed as CPython's is, because we're doing the same amount of dynamic work. So you have these cases that are made 100 times faster because we're able to use the .NET functionality directly. And you have other cases where all of our performance work has been don't make them slower. And that winds up giving us the performance boost that we see in IronPython. That's not a huge one. Now, each one of these places is, of course, an opportunity. Okay, so the performance story of IronPython is use these native common language runtime constructs whenever possible. They generate ludicrously optimized machine code. Okay, they can be 100 times faster than a bytecode interpreter. Also, by using these constructs, you're leveraging the hundreds of developer person years that are being put into driving .NET forward. So the closer that a language can be built on top of .NET, the better. But the second key is, you know what, it's actually hard work taking a language and building a really serious production quality language implementation. .NET makes it easier by giving you a whole lot of things to take advantage of, but it doesn't make it easy. You still have to work hard to build a good compiler. You need to measure, make sure you understand where all of your performance bottlenecks are and you make them go away. And you need to make sort of lots of, hundreds of small decisions. Each one needs to be made right. Okay, so that's the performance story, but performance is not the main key of the IronPython story, and I'll just drop some things from this part of the talk. The main part of the IronPython story is have good performance, okay, because you need good enough performance that people are happy to use this implementation. But also be a true implementation of the Python language. Support all the dynamic features that the language has, like adding fields, changing methods, even changing types of instances at runtime. Okay, running the existing regression tests unchanged, being a true implementation of Python, not Python.NET or Python Sharp or some weird corrupted language. At the same time, be seamlessly integrated with .NET. Be able to use all of these rich frameworks that are available simply and easily, okay, so that when something cool comes out, like WPF, sounds cooler if I call it Avalon, doesn't it? When something cool comes out, you're able to just use it, and you're able to use it from the language without having to build up a whole bunch of wrapper libraries. And you can even use libraries like GTK Sharp, which is a wonderful library out there that happens to have easy .NET bindings. It works directly, and to do that, you need deep integration like subclassing types. So Python needs to be able to subclass .NET types and implement interfaces. You also want to integrate with tools like Visual Studio because, quite frankly, these tools are pretty cool. Yeah?
Battery goes out, just turn it on and use that.
Thank you. Seems to be working now. So I'm going to give you a quick demo of .NET integration, but this one's going to be really quick. Let's see. We'll raise this up so people can see it more easily. Every demo has Okay. 2 plus 2, 2 to the 64. Working again? Okay. Those two both work great. I can also import system. And now I can start looking for interesting things in system. System.environment is one of the classes that's in system. I can use tab completion to page through all of these things. What are some of the cool things in system.environment? There's current directory, so I can print that out. So I can just use this .NET library. It's not being wrapped, but I can use it from Python just as if it was a Python library. And it feels like a Python library to the Python programmer. Now, one of those cool libraries that I told you about is this WPF library. So let's bring all of WPF. I can't type and hold a microphone at the same time.
Your lovely model here.
Okay. I'm sorry. Okay, so I can create a new window here. This is a regular old WPF window, right, that I'm creating in IronPython. I can create a button. Oh. I should have held the microphone because then I could have blamed it on anything that went wrong. And I can stick that button in the window. So now the window has this big, giant click me button. Okay, it's not properly giant yet. Size equals 100. There we go. Now the window has this big, giant click me button. Which of course does nothing, which I find fairly obnoxious to have a button that big saying click me that does nothing. So I define a little function in Python. This is just going to print the arguments that it's called with. Not very interesting. And assign this function to be what happens when I click. So now I click the button and it calls the Python function. I've got Python and WPF working well together. But of course, to really work well together in a GUI framework like WPF, you often have to subclass types. So here I'm going to create a Python panel that subclasses the .NET panel, the WPF panel type. And I'm going to define the onRender method to do something really sophisticated. Okay? And create a new instance of my panel. So I'm creating an instance of this Python type. I'm going to make that the content of the window. Okay, now you see it prints rendering once, and as I resize the window, it keeps printing rendering. So I'm able to take this Python class, stick it into the .NET class hierarchy just fine, and it's very happy with it, and all of the callbacks work, and I can override methods. But it's still a real Python class. And to prove that, I'm going to import a collection of some other panels that I've pre-written. And I'm going to change the class of this. So in Python, I can say p.under_class, and this tells me what the name of the class is of this object. So here you see it's this my panel that I defined. So this is the class object. Now I want to replace that with a different panel. Replace it with a new panel. Okay, so now I've changed the class, and when I resize, I've changed the panel that I have here. So I'm able still, even though that this type works well with .NET, it's still a Python type, and I can change it around dynamically at runtime. That's because I just replaced its type. It's not a my panel anymore. Just to be clear, p.panel now is a new panel. So it's the same object, but it has a new type. It loses the event handlers? No, it wouldn't lose the events handlers in this case. I didn't wire up any event handlers. The onRender method was a method that I was overriding. And so it gets new overrides of the methods. And I can set it to fancy panel in order to properly finish a WPF demo. There needs to be a gradient, a color gradient at some point in every WPF demo. I think that's in a handbook somewhere. Okay, that's all that I want to show for my IronPython.NET integration. That would be great. Thank you. Okay. You know, usually when I think demos are going to go wrong, I finished writing most of the rest of this talk after 1 o'clock tonight, so I thought that anything would go wrong would have to do with my demos not working. So .NET integration, you've got all the sorts of functionality that you want. You know, you can create new instances of things, you can set fields, you can set event handlers, you can deal with overloaded operators, you can work with indexing. I didn't show this, but this is how you'd work with a generic type. I can create a list of string in this case, and I can add strings to it, but if I add an int to it, I'll get a type error. So all of the basic .NET functionality and integration works. Visual Studio integration is the thing that we always get asked. What I love about the Visual Studio integration is it's been developed in the same way IronPython has. IronPython is fully source available to folks. We want people to go out and play around with it, mess with it, let us know how well it works for them. The Visual Studio is also shipped as a sample, as part of the Visual Studio sample development kit. They ship a full working IronPython implementation written in 100% C#, which I think is nice. It used to be that you had to write C++ code to extend Visual Studio. Now you can do it in C#. And they include the full source code in the Visual Studio SDK for an IronPython integration. Yes?
Big question outside there in internet. If, let's say, I try to use this package to integrate my own language, can I do this in open source arena? Or Visual Studio SDK license prohibits me from doing this?
Does anybody in the room know the answer to that?
You can repeat the question.
The short answer is it's a licensing portion. I'm actually getting you the SDK person based on a live conversation so that they can answer this directly as opposed to our answer their license.
So I'm going to just give that. There was a licensing question about VS SDK. I don't know the answer. We're going to find somebody who does at some point in the future. Okay, and the rest of the answer is it looks like they're getting more open on that issue, but I still don't have a definitive answer. So here's what the integration looks like. See IronPython code over here. Even things like IntelliSense work partially, not in every scenario, but here you're seeing IntelliSense working on a very simple IronPython program. The debugger works. Here I've stopped, set a breakpoint in my Python code. I've stopped, I see I have x and y, the two values the functions was called with. I also have some additional stuff, some implementation details down here, which is unfortunate that we show both, but you can see all your local variables. The debugger will work, let you change them and things like that. And part of the fun is you see, I actually like this mixed stack trace if you have C# code and Python code intermixed with one another, and you can jump back and forth between them. If you've ever written extensions to a scripting language in C, trying to debug back and forth between your extension and the scripting language can be just a disaster. Having the ability to have them integrated in a stack trace and integrated in one debugger is a wonderful experience. And lastly, the interactive interpreter that I showed you before. Of course, there's a spiffier one if you have Visual Studio. Instead of tab completion, you get the lovely IntelliSense popping up for you. Mind you, all this Visual Studio is part of our software development kit. It's a sample. It's not. Okay, so part of our getting Python compatibility working is the Python regression test suite. This is the sum total of the Python regression test suite we produced in March 2005 when we first released IronPython from Microsoft, IronPython 0.7. I hope you're all very impressed. We've been doing a little bit more work since then. And these are not individual tests, right? These are test files having about 100 tests in each of them. So this is a fairly large number of tests that we run successfully. Running the actual Python regression test suites to keep us honest that we really are a true implementation of Python. Now it's interesting, it keeps us honest. It also keeps the Python developers honest. One thing I love about working with the Python community is that they want to be honest about these sorts of things. We're not 100% perfect in running the regression tests. There's some tests that we skip right now. They're tests that test things like whether or not you have a reference count or a mark and sweep garbage collector. And they depend on the reference count based garbage collector that CPython has. There's other tests that depend on things like the ordering of keys and the particular hash table implementation inside of the CPython interpreter. Now, when you talk with the Python code developers and they look at these, they say, oh my God, how did we write that? It's not as if this, they come back and say, well, yep, you know what, that key ordering algorithm we have, that's a deep part of the language. The more interesting one is they don't even say, that reference count based GC we have, that's a deep part of the language. Something that I really like about this community is they say, well, we have that, it gives us some properties, but we'd hate to restrict the ability of our language by saying it depends on a particular garbage collector in order to be a true Python implementation. So we're able to have good discussions with these, and basically the Python code developers like the way that we're cleaning up the test suite in some of these cases. We're missing some built-in modules. Some of these are OS-dependent modules. So some of the regression tests we don't run are things like modules that depends on running on OS 10. It'll be a little while before we run those modules. Others that depend on running on SGI, which will be even longer until we support running on those, or Sun OS specifically. So there's a number of machine-dependent modules. Then there's just some standard C-based modules that we haven't translated to C# yet. And that's just work. And that's our fault. We're missing them. We'll do the work. We'll fix it. IronPython also does have bugs. By the way, I sometimes, whenever you're talking about how compatible you are with something, we try to be 100% compatible. Most of the time, if we aren't compatible, it's a bug. And we do have bugs, and it's not that we're trying to, it's not part of our evil plan to destroy Python, but it's that we haven't gotten around to fixing the bugs. This is my favorite one. The type of type is type. In IronPython, it's actually a subtype of type, and I don't have anywhere near enough time to start going down the metaclass hierarchy to explain why a subclass of type worked for us. But we do need to fix that. That's just, we got that, some corner cases and things like the meta model we got slightly wrong. But its type still is a type. Instance of. Anyways. Okay, and I'm going to, let's see, do this very quickly. Simple question. So I have a string here, and I call a trim method on it. Anybody who's a .NET programmer know what that should do? It should trim it. It should return py, right? That's obvious. It should call this .NET trim method. That's what it should do. You know what a Python developer tells us? It better throw an attribute error. Because in Python, strings don't have a method called trim. Now this is really frustrating because both people are right. Okay, the .NET developer is 100% right. The whole story of IronPython is we want to have this huge, rich platform that we can leverage. You learn about the platform once. You don't need to relearn a new platform for every language. You can reuse all of this framework. So you bring it to Python, you come to IronPython, you get to use all of your .NET experience. The Python developer is also right. Look, you guys are trying to be 100% true Python implementation. You can't go around adding methods to string. Well, for a long time, this really sucked because we didn't know what to do. Then we were inspired by a feature that Python came up with to deal with changing things in the future. This is actually, we have a new inspiration for this, which is C#'s extension methods. Because what we're really doing is just like the extension methods that they added to C#. So let me explain it that way. What we start with is just the Python methods. Because when you bring up Python and you haven't done anything, it sure better be Python. So here you have the string. You type strip, and it returns py, because this is the Python method that does it. You type capital trim, and it throws an attribute error. Python programmers are ecstatic. .NET programmers are a little bit angry at this point, but they're willing to get over it. Because we tell them, well, all you need to do is say import CLR. And if your module imports the CLR, and this is at a per module level, so we don't affect the whole world. We don't go and add these methods to every string. So you can have pure Python modules that never import the CLR. But every module that actually imports the CLR and wants to have CLR functionality, strings in that module have these additional .NET methods. .NET programmers, almost every program that uses .NET functionality has to import CLR, as we'll show you a little bit later. So it's not that much extra burden for them. Yes? So the question is, if calling trim is an error in standard Python, why don't we just let it work? And this is actually interesting because in Jython, which is the previous implementation of Python that I built on the JVM, we just let it work. And nobody ever complained. For some reason, I think it might have to do with my new employer, but I'm not sure. People are a little bit more paranoid about the level of compatibility that we're producing. The good news is I'm somewhat sympathetic to why they have this compatibility. So here's the reason why. People want to be able to split up their code base. They want to be able to say, we're going to write pure Python code here that will run on any Python implementation in the world. We're going to write some other Python code that will run on .NET. And by us letting capital trim through into the pure Python world, it's too easy for developers to do the wrong thing and accidentally build code that depends on IronPython when they don't want it to. So we're doing the right thing to let people stay pure Python when they want to and only bring in .NET when they ask for it. So it was kind of unfortunate that we were first beaten up about it, but I'm happy with the solution. I'm not going to talk about strings, except to say Python used to have has Unicode and ASCII, which is a pain for everybody who has a pure Unicode system that you want to run on top of it. Python 2.3 is going to use pure Unicode strings, which is wonderful for all of these alternative implementations, finally. Sometime before the year 3000, we've been promised Python 3.0 will ship. So to finish up my IronPython part of my talk, IronPython 1.0 Release Candidate 1 is out there on the web right now. I believe we have about 5 bugs right now that we know we need to fix before the final, so we're really getting there. I don't know if there's going to be an RC2 or not, but there either will be an RC2 or we're going to ship an RCM next. It's on codeplex.com. Anybody who hasn't been there, codeplex.com is a wonderful new sort of shared source, open source site from Microsoft. Download it, use it. It ships with the tutorial that shows you how to use it. Goes through the kinds of things I did in my example in much more detail. We also have a live source repository. The source is under a BSD style license. It's a license that says you can take this code and put it into your commercial application. So for IronPython, I could have answered this a lot more easily. IronPython license is designed so you can take the code, put it into your commercial application, and even make it closed source if you want to, although that's not a very friendly gesture, but it's designed to enable that if that's what you want to do. And it even has an architecture.html file, which will give you a good 3 pages worth of architectural information. We got to work on that file. Okay, so moving into the second part of the talk. There's other dynamic languages on .NET. Is my mic still working? Okay. Ruby. Everybody in the audience has heard of Ruby, I suppose. I've seen it mentioned once or twice in the press, once or twice on blogs. Okay. Once or twice. We've got lots of things going on with Ruby on .NET here. John Goff gave a talk this morning on Ruby on .NET, on Ruby.NET. John Lamb's going to be talking on Wednesday on his bridge in Ruby, Ruby CLR. Wilco Bauer, who may or may not be in the audience, but has been off and on, also built Iron Ruby, which of course is the Ruby implementation with the best name. There are other dynamic languages, though, from Microsoft. PowerShell is a cool dynamic environment that I'm going to talk about in just a moment. Bruce Payette will be giving you a lot more details about that on Wednesday, and I just realized I need to learn how to pronounce Bruce's last name. Visual Basic you all may have heard of at some point as well, and Paul Vick will be talking about Visual Basic tomorrow. Fortunately, I don't think I need to learn how to pronounce Paul's last name. Not to mention William Cook tonight's talking on AppleScript, which isn't dynamic languages on .NET, but
it's not a .NET implementation.
So this is the not to mention. There's also some other dynamic languages things going on that are not dynamic languages on .NET, but I think I happen to like all dynamic languages, so I wanted to give quick plugs for these anyways. Talking on AppleScript. Gilad Bracha, I believe, also is not going to be talking about implementations on top of .NET, but I have some vague hope that Jython will appear at some point during his talk, talking about dynamic languages on the JVM. And I'm sure there's something I forgot, but if so, I apologize. I want to first talk about PowerShell, which is one of the Microsoft dynamic languages. There's a URL you can find to find a lot more about PowerShell. They have better than codeplex.com/IronPython. It's a shell environment and a scripting language. It's a command line shell plus an object-oriented shell-style scripting language with deep integration with existing .NET libraries. So it's another one of these .NET languages that can use all of the value that you have in the frameworks. So if you happen to be looking for a shell-style language, PowerShell gives you that language as one of the .NET languages that you can use with the rest of the framework. If you want a language like Python, you have that. This language choice is one of the things that makes me really excited about .NET. It also, in addition to being this environment, though, it's got a bunch of libraries that they've built up for making administrative activities really easy and in a dynamic language style. It ships with a bunch of core Windows administrative functionality out of the box, plus some new tools that we're going to be shipping, Exchange Server 2007, some minor releases coming out of Microsoft. System Center Operations Manager 2007 are all going to have Monad integrated with them, and in particular some libraries that are very well designed for this admin kind of developer, but very amenable to dynamic languages. So I want to give you a quick demo of integrating PowerShell from IronPython. Before I do that, so you'll appreciate it, here's the quick demo of using PowerShell from C#. And notice I'm leaving out all of the setup and the 20 using statements that is at the top of every C# file. So here I go. I create a pipeline. I create a get service command. I add the parameter name is a star to the pipeline. I invoke the pipeline, and then I render the objects of the result. And that's how I do get services from C# and Monad. PowerShell. PowerShell has recently changed its name from Monad to PowerShell. I'm still working on it. OK, so quickly, what would that look like from IronPython? Possibly, although the next demo is going to be more interesting that way, but I'll do this for now. Is that high enough?
Yep.
OK. So I just imported all of PowerShell. And now I can do things like let's do get service, which was the thing that you just saw there. Name equals a star. Right. And that does the get service of all the things with the name of a star. And OK, well, let's say that actually what I wanted to do, PowerShell has this immense pipeline kind of notation to it. So I want to sort them by their status. OK, they're sorted by their status. Convert to HTML. Convert to HTML. OK, that's a little bit too much, so let's run it to a file. We dump it to t.html, and I can open that, and that's got an HTML version of all the services on my machine. So what I find so cool about this is, the folks who built PowerShell spent a lot of time trying to come up with what were the commands that made it easiest to do some of these common Windows administration tasks. And they came up with a bunch of commands that worked well, and they found that, being a command line tool, as you often find, they needed a fairly dynamic architecture in order to make it work well. Well, from a dynamic language, I can use these PowerShell functionalities roughly as easily as I can in PowerShell itself. So there's this lovely integration, and now I've got a new set of libraries that I'm able to use from IronPython. Let's see, the one other thing I want to show is shell.get WMI object. Does anybody know what WMI is? WMI is the standards Windows management interface. The reason that took so long is there's one or two little WMI objects on my machine. This has been the way of administrating Windows through the years, and I don't think you can find anybody who actually says they enjoy the standard ways of working with WMI objects. Now, PowerShell gives you one way that makes it a lot easier to work with WMI objects. I happen to like all of the things that they did to make it easier to work with WMI objects, except I still want to program in Python. I know that's annoying. But I can do that. I can go grab one of these programs, copy it, paste it in there. Okay, so now I've got the WMI object for all of these add remove programs. So this gives me all of the programs currently sitting in add remove programs on my computer. And it even integrates with Python. So let's say I want to create a Python list of just the display names of them. I could use the PowerShell composition, but I'm going to use a Python list comprehension instead. Git. Paste. So this is going to get all of these WMI objects, and then I'm going to pull out the display name property into a Python list. So now I have this list of all the display name properties. And I can print the name. So those are all the things currently sitting on my system. So I'm able to use all the PowerShell stuff, and it's able to integrate nicely with this Python dynamic language. And I think that's a lot of fun.
Jim?
Yes?
So I may be sort of missing the point of the demo here. Because
Yeah.
I remember, I don't know the details of WMI, but things like this we've been doing with using COM interfaces from other dynamic languages for a while. So
Yeah.
what's different?
So a lot of this isn't fundamentally different. What this is showing, though, is PowerShell has built up a new API that's made a lot of these things. They've spent a lot of time in API design, trying to make their APIs very easy to use for admins. So you could say, if you think PowerShell is just another version of COM, there's nothing different. So this is in many ways retelling the story that you would tell about COM with PowerShell. Fair enough? Okay. I do have a different story coming up soon, though. Okay, so what made this integration with PowerShell work so well? And there is something to this. Again, it gets back to the COM, but people who aren't familiar with dynamic languages don't necessarily know about these features. IronPython has this dynamic environment that makes it easy. There's this interactive console, so I can work with a shell-style API very well. There's lots of concepts that are shared between IronPython and a shell language. Callable objects, so I can turn PowerShell commands into Python callable objects. That's how I'm able to call them so easily. These named parameters. PowerShell has, of course, this shell-style naming convention. IronPython has a slightly different way of passing in named parameters, but they both have named parameters, so they work very well together. Without these features, the code would look really ugly, right? You'd have something like this. This is trying to be pseudo C# 3.0 plus IronPython to sort of capture what it would be like to do this without having named parameters and callable objects in your language. There also are dynamic features. One import brings in everything. I don't have to write 20 using statements in order to get everything I want to into my namespace. I have dynamic attribute lookup, so I'm able to do method missing. Again, method missing is not exactly a brand new invention, but having method missing makes a lot of APIs easier to work with. And simple metaprogramming. One of the things that I do is I do some metaprogramming in order to make the PowerShell objects more easily available on certain Python types. Okay, I have 15 minutes left. That's more than enough time to handle Visual Basic, right? Okay, so Visual Basic, I was going to write a slide explaining to everybody what Visual Basic was, but I felt that of all the languages, Visual Basic is the one that needs no introduction. Who in this audience has ever written code in BASIC or Visual Basic? Yeah. I don't think there's any other language I could have picked that would have gotten everybody in the room to raise their hands. C? Okay, fair enough. PowerShell? Python? Thank you for that. But Visual Basic is the one language that virtually everybody in the world has written some code in. And in a different audience, by the way, I would still get a fairly large fraction of Visual Basic programmers. And if this wasn't a whole bunch of compiler implementers, the C number would go down dramatically. Visual Basic was my first programming language. I learned it when I was in 5th grade on the very first IBM PC. And I used it to write a breakout program. And it was so cool because it fit my brain easily, and the whole interactive nature and the way that I was easily able to play with it. This was Basic A, of course. Was a lot of fun. Now, VB.NET lately has been getting a fair amount of bad press. And one thing that VB.NET I think has been called is a more verbose C#. I actually think there's, well, let's not point any fingers. So this is an event handler in C# from the MSDN documentation. As you see here, it's getting in an object. It's taking the sender, which it knows must be a list box, so it does as, so it'll get a null pointer exception if it isn't. Gets the selected item as a list box item again, because they really want null pointer exceptions if things go wrong. Well, you convert that into VB.NET, and oh my God, it is a more verbose C#. It gets so much more cumbersome. This is again what's in the MSDN documentation explaining how to do this event handler. Well, you go and look at this code, and everything in red is not needed in VB. It's needed to make VB pretend to be C#, but it's not needed in VB. If you get rid of it, the code turns into kind of what I'd like to write in a straightforward dynamic language. Right? It's late bound. VB is a late bound language. I'm able to get the sender. I can get the selected item out of it. You compare it to the C#, it's actually a much more succinct and straightforward way of writing the same event handler. Oh, I know, but you say, but the C# is strongly typed. So this is good type safe code, and this is dangerous late bound code. Nobody really believes that for these two samples, do you? I mean, clearly I picked an extreme, but in this case, if you happen to get the types wrong, the C# code is going to throw a null pointer exception. Who the heck knows what happened when you get a null pointer exception? If you happen to get these wrong in VB, you're going to get an error message saying sender is a string. Strings don't have an attribute selected item. You're going to get a wonderful error message out of it. So this is actually much better code than this down here for this particular scenario. So one of the things with VB is, you know what? It actually can be used very well as a dynamic language. People don't tend to, because in the .NET world, they tend to be trying to mimic this. Oh, I do have time to do this. Excellent. So I took a quick look at the VB.NET implementation, and this is compiling factorial to IL in IronPython again. Here it is in VB.NET. This on the left is VB.NET. This on the right is IronPython. What you should notice is the code is really similar. And this is the standard VB.NET implementation. They both do the load arg0. I think, that's the one thing you're going to see everywhere. IronPython is using static fields to hold its constant pool because it's a small optimization over boxing the constant every time. We spent a lot more time optimizing our late bound code paths, I think, than VB.NET did. Then they both do this call to the compare equal method because they're both dynamic languages where compare equal can be a fairly dynamic thing to do. You'll notice here this is where VB has a real improvement over us. They only call this method, call one method. We call two, one to call equals and one to convert it to a Boolean. They sensibly realize the equals ought to return a Boolean. The branch is the same, the boxing, the return. It's extremely close. In fact, close enough that we can steal the good ideas from VB back into IronPython. And the current version that we're shipping only calls one method here. And that's the beauty of being on a 3-week ship cycle. Is we can just go in and fix this one. If you look at something like return x.myField, which is a late bound attribute lookup, again, they look really similar. And I want to be sure to get to the demo. This is here we're loading a symbol. So IronPython is using symbol objects. John alluded to this in his talk. We use integer symbol objects to represent all of our names because we can do very fast lookup based on that. VB, like most other dynamic language implementations on .NET, is using strings. But other than that, we both call this late bound getAttribute function with a string and the object that we want to do the lookup on. So it's extremely close. You would think that it would be close enough we could bring these two languages nicely together. So let's see what we can do about bringing VB and Python together. First of all, you all know about my in VB? Okay. So one way that we can bring them together is I can import my, which is this nice little namespace that VB added to make it easy to get at simple things. So in this case, the simple thing is my computer, audio. Say I want to play. Ta-da. Okay, so I can use my easily from IronPython. So that's kind of like the PowerShell integration, right? VB has this library. I can use it from Python. Of course, I'd rather use it from a language that felt more natural for my, right? So if I bring up a quick little prototype VB interpreter, turns out VB and Python are similar enough that this particular line of code I can copy and paste. The only difference is you don't need to import it in VB. And it still works. Now, of course, in case you were wondering if this really is VB, this felt so much fun when I wrote this. I wrote this last night, by the way, and it really had been, I'm not going to admit how long it had been since I'd last written a VB old for loop with step statements, but it brought back a lot of memories. So, that's a simple VB style for loop that does for loops, next and steps and all of that sort of good stuff. But now, you remember I told you I wrote this Python module to make PowerShell easy to use from Python. Okay, people do that all the time. Now I'm going to take this a different step, and it's not going to be just like the com story before, because I can use that Python module that I wrote from VB. So this is loading in the PowerShell module, importing it dynamically into my VB runtime, and I have the shell again. And here I can do a shell.dir, one of the commands on shell. Right, and of course, the same way that it's not an Avalon demo if you don't do gradients, I don't think it's truly a PowerShell demo if you don't show doing a directory over the registry. So now I've properly done both an Avalon and a PowerShell demo. But again, here I wrote this integration library using all of the dynamic features of Python over as a Python library, and being able to use that same library, that same helper library in VB is wonderful. Of course, I can do the WPF stuff as well. This demo first started working at 1 o'clock last night, by the way, so if anything goes wrong. So here I can create, I loaded in WPF. I can create a new window, show it, yay. Where am I going to put the window? This is going to be a problem with everything up so high. We'll do our best. Okay, there's the window. Let me quickly do the button. You'll notice VB has the same named parameter stuff that Python and PowerShell do, right? This is a fairly common thing that you find in dynamic languages. So there it is. I better make the font size big because it's just not as funny if I don't. And then I can create a VB subroutine. Sub, do it. And I want it to handle b.click. Right? So that's the way that you specify handlers. And I'm going to print clicked. Okay, and in the subroutine, and now I've added the handler, and this always bothers me because I desperately want to type plus equals here. I think it says something about how much time I've been programming in Python and C#, but I don't need to because I've already registered as an event handler, and in fact it does print click when I click on it. Okay, now's where it's going to really get fun. So now I can load in a XAML file, and there we go. I've got my XAML file, I've got my calculator. Let's move this over. Okay, now I want to get all of the buttons in the calculator. So I'm going to create a new array list. For each node in walk calc. So I'm going to walk all of the nodes in the calculator. First I'm going to print the node. It's a function in VB rather than a statement in. Then I'm going to do if type of node is button, buttons.add node. I need to end the if. Okay, now I walked all the nodes, and I should have all of them sitting in a collection of buttons. We'll find that out quickly. Now I can do b.font size equals 30. Oh yeah. So I did in fact gather up all the buttons. Now I can also walk all the buttons and do b.layout transform. Rotate transform of 30 degrees. Why not? There we go. All the buttons are lovely. I can bring in references to other .NET libraries. Now this is a thing usually when you're writing your code, references are something you add in your project and you tell the compiler about. Well, adding a reference needs to be a dynamic operation in a dynamic language. So I'm going to add a reference to system.speech. Okay, and I'm going to imports. Synthesis. There we go. And I create a new speech synthesizer. Okay. Okay. Well, I think I'll leave out the speech part of this. We've been having fun audio problems, by the way, today, trying to get the audio of my computer to work right. Well, let's just try quickly. Nope. Okay, well, that's what happens when you write your demo at 1 a.m. Okay, but I can still get out of this demo. So that still was doing a fair amount of VB code. Now, just to let you know that it can do things larger, here's Merlin. Merlin, for those of you who know, has been kind of the mascot of IronPython all along. Here's Merlin written in VB. This is going to use system.speech. It's going to use it more aggressively, and oh my goodness, this will be fun. Any of you, being a Microsoft employee demonstrating speech recognition really is a badge of courage, so be with me here. I'm adding references to the agent class. I'm loading in some standard COM objects, done that before. I'm also loading in some WPF objects. I'm creating a grammar that understands everything that the agent knows how to do. I'm adding into the grammar all of the animations that the agent knows about dynamically. And I'm going to try and get him to perform the animations for you. So, here we go. Okay, and Merlin.py would make me feel more confident today. There he is. Wave. Gesture right. Look at this wonderful VB code. Don't recognize. Process. Search. Search. Announce. Congratulate. Exit. The best thing about Merlin, of course. Okay, so I told Jim at the beginning I was going to take 5 extra minutes, and I'm going to, but only 5 extra minutes. So what made IronPython and VB able to integrate so well with each other? Well, I do have to admit, a lot of this is going to sound like the COM story. One thing is, they were able to share this dynamic environment. So I was actually reusing, if some of you looked up at the top, you'd notice that it said IPY shell up at the top. I was reusing our shell, because we'd spent a fair amount of time building an interactive console that we could use easily. So I wanted to reuse that. So in order to reuse that, well, they need to use the same language engine hosting API in order for both of them to be able to use the same console. So that's something that they need to share in order to be able to use this environment. They need to share things like the notion of a callable object. In this case, there's an iCallable interface that we used in order to make a notion of a dynamically callable object. They need to share the notions of named parameters. Well, okay, they share the notion of named parameters. That's a wonderful advantage that you have. But they need to use the same method invocation APIs, or at least the same underlying method invocation, dynamic method invocation logic, so that they'll both be able to use named parameters in the same way. And they can both use libraries that use each other's named parameters seamlessly. Plus, there's a bunch of dynamic features. One import brings in everything that you need to use PowerShell. One import brings in everything that you need to use WPF. So they need to have some namespace inspection APIs that are the same. Dynamic attribute lookup, this method missing grand innovation that we've just come up with, let me tell you. And to do that, they need to share kind of an iDynamic object interface, some interface that lets you query objects dynamically for what they can do. And they both need to use the same interface so that they can share the same set of objects and they can pass objects back and forth. And this simple metaprogramming that was a piece of getting at a lot of this dynamic namespaces and namespace inspection and dynamic attribute lookup, that's what gives you a lot of the simple metaprogramming that you use to make a lot of these things work. So quickly, the picture that I see is, you all know we build systems in layers, right? Down here at the bottom is the hardware, okay? Is the processor, it's also the memory, the buses, all of that stuff. We stick layers on top of it where the operating system, Windows, of course, being the only operating system, except for those funny little boxes with apples on them I see here. The operating system is layered on top of the processor. The common language runtime is layered on top of both the operating system and directly on top of the processor. The fun thing about IronPython is it purely sits on top of the common language runtime. It never talks directly to the operating system. It never talks directly to this hardware. This means that we've got a really strong foundation to build on top of. We've got a verifiable type-safe foundation to build on top of, rather than having to build on top of these low-level stuff, which can get you into huge amounts of trouble. But IronPython has within it its own Python type system and its own Python hosting APIs. So IronPython 1.0 RC1 that we just shipped, it works great in its own world. And it works great with everything that runs on top of the Common Language Runtime. But it doesn't work well with other languages that might have their own dynamic type system and their own dynamic hosting APIs. And what I'm hoping we can figure out how to do next, what comes next after IronPython, is figuring out how to pull out this chunk, pull out a dynamic type system, pull out script hosting APIs, so that IronPython now can be built on top of both this and on top of the Common Language Runtime. So this kind of feels like the OS in the picture to me. But this is the piece that everybody needs to share, that gives people a lot of benefit and that everybody can share. And then we'll, of course, see foolang built on top of this. I'm sure somewhere there is a foolang. Let's see. I'm going to blow through this slide. But the idea of, to get scripting successful, there's some things down here at the bottom in the Common Language Runtime. There's some things on top of it we can provide in terms of dynamic libraries and hosting APIs and all of this dynamic interoperability runtimes. But where the stuff really starts to get exciting is when you see the languages and IDEs on top of that. Okay? And anybody who's really worked in the scripting world knows that really what makes scripting languages successful is this stuff up here that happens because of the stuff underneath. But it's the communities on top of it. I've painted this in yellow. The parts in yellow are the things that we know how to do. That basically I think we can drive and we can make this stuff happen to have this part happening. But what I'm hoping is, and I'd love to have people talk to me, the rest of this we need to have happen too to really make scripting succeed on .NET. And there's a whole bunch of it that needs a much larger effort than we can directly provide. And we need to be sure that this is right so that everything else on top of it can be built right.
Question. Does the I guess the language developer, does he have to know or familiar with the just-in-time compiler to take advantage of it, or is that something that CLR does transparent?
So this is a great question. It's how much does the language designer need to know about the just-in-time compiler in order to use it effectively? And there's kind of two answers to that. So today the story is actually pretty good. We have a lot of APIs that let you generate this IL, this intermediate language, which is a fairly nice language to work with. It's a standard stack-based virtual machine. Many languages target that kind of machine anyways. Once you've generated the IL, you don't need to know about it. The JIT is all taken care of by the runtime underneath it. Now, part of what I'm excited about, though, by building some more infrastructure for dynamic language folks is you have to do some pretty crazy things in generating IL to make even things like dynamic method dispatch work really, really fast. We'd like to provide some standard libraries there, too, so that the language developer wouldn't need to know even how to generate that fancy IL, but could just say, make my dynamic method dispatch fast. Let me talk about status to clarify that a little bit, though. So status notes on everything. IronPython is in 1.0. Release candidate 1's out. It was released less than a week ago. It's in production use today. It's actually been in production use for about a year. The fact it's been in production use for a year scares the heck out of me. But right now it's getting to the point where we're saying you can use this. Take IronPython, go forth, do cool things. Visual Studio integration is an SDK sample. Okay, it's not a finished product. Okay, it's a sample. On the other hand, it's a sample with source code that you can go fix if you don't like exactly what it does. PowerShell integration with IronPython. PowerShell is also a 1.0 release candidate, oddly enough. I think they're also due for a 1.0 RTM in August, but I'm not sure their exact dates. But they're due for a 1.0 RTM real soon now, too. The integration that I showed you is a rough prototype. I actually cooked it up with Bruce's help over the past few days. But it's easily extensible to something real. The PowerShell integration that I showed you is a simple Python file. It's actually something I think we should ship it as a sample really soon to let Python programmers in PowerShell start playing with it and pick on it. The Visual Basic stuff that I showed you. Well, Visual Basic, by the way, is a little past the release candidate stage. VB8 shipped, Visual Studio 2005, in case you haven't heard of it. It has some dynamic language features. And I was showing you how to do some dynamic language code in VB. VB9 is going to ship in the next Visual Studio release. Paul Vick, I'm sure, is going to tell you a lot about the cool things that are coming out in the next version of VB and VB9. This interactive console that I showed you, and this, with the very dynamic features and the integration with Python, and this whole notion of having this deep dynamic language integration is currently in the earliest prototype stages. Okay, it's a rough prototype. We don't currently have any, announced commitments to that, but I'm sure we're going to do something in the space to make this happen. So this is in kind of the roughest, earliest stages. On the other hand, that's the stage where input can be the most useful. So I've got to finish, and then I'll see if I have time for a question. Otherwise, I'll be around. So my quick conclusion. IronPython 1.0 is out today. It's a true implementation of the Python language that's also seamlessly integrated with the .NET. And by the way, it has good performance. .NET's a great platform for dynamic languages. Okay, IronPython shows how well it can work, that you really can be true to the dynamic language and yet have good performance and good integration with everything else. VB and PowerShell demos show that this isn't some isolated thing. There's lots of great potential for other dynamic languages working together on .NET. We've got more language and interoperability work to do, and that's clearly what happens sort of in the beyond phase. And finally, I think what IronPython taught me is you can please all of the people, well, at least some of the time. And thank you. And I will take 2 more questions only.
Okay, the first question was, obviously you have one direction interoperability from IronPython to C#. How about from C# and other static languages and CLR back to IronPython?
Right. So the question was, interoperability works great when IronPython is calling a static language like C#. How does it work when a static language like C# wants to call a dynamic language like IronPython? The bad news is today, you remember that PowerShell slide I showed you? This is often the kind of thing that it looks like. Okay, so it works, but it doesn't work particularly seamlessly. Now, yeah, I need slides. I need fewer slides. So, and part of this is because we've deliberately built the dynamic language stuff on top of the static. Now, I think that this is not such a bad idea, quite frankly, because I think dynamic layers very nicely on top of static. And then for any given project, you need to decide whether you want to, parts of your project, are you going to build in a dynamic language or a static language? If I was building, the next version, some low-level, list APIs. Right? If I'm building list APIs, I want to write them in a static language. Okay, I can get a lot of good properties out of that, and everybody can use them effectively. If I'm providing an API that's designed to, wrap some thin layer on top of something to make it friendly to script developers, that might be in a script language, and it might be hard to use from static languages. We've got to work on making that easier in the future. But let me give you the other half of the story. So that was the excuse as to why it wasn't the most important thing to do. The other part is we deliberately didn't do it first. So I think it's a good thing to do ultimately, build better integration from static to dynamic, but it puts some dangerous constraints on the dynamic language. I think you could point to some dynamic languages in the world that have really worried a lot about integrating well with the static side and being callable from it, and have lost their dynamic feel as a result of doing that. And we wanted to make sure we didn't do that. So we wanted to make sure we had a complete dynamic implementation first, and now we can start looking at going back the other way. But so we don't have a great story going back the other way. Thank you. Thank you for the question. And that's good. I think it was only one more question. Oh, last question if there is one. Otherwise, I'll be around all day. Great. Thank you very much.